Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel of things that have to do with science and math. And this is chemistry. This is the optional video for Chapter 7 that I told you was a little bit more honors level. And so you can learn this or not, depending on how deeply you want to learn this material. But this video, I'm going to be pointing the camera toward the book here so that you can kind of see what I'm talking about, because you need to be able to see a little bit up close about some charts. So the first thing is predicting products of chemical reactions. And the thing I want you to know about this is not all single replacement reactions, just because you can write it, doesn't mean it's actually going to happen. And if you remember that the single replacement is where you have, and this is our little example, T cuts into RS. So T and S get together and R, poor little R, has to go off by itself. But not every element who would want to cuts in. So how you figure out if it's really going to happen or not is an activity series. Now there's a way to tell this just by looking at the periodic table, but usually on the high school level you're more going to have one of these charts and you figure out if it's strong enough to replace what it wants to replace or not. So here, can copper replace hydrogen? So you look at the little chart and here's copper, and if hydrogen is above it, actually this one doesn't have it, my one at school has it, then if an element is above it, it's stronger and it can't replace it. So like if copper wanted to replace lithium, it could not. But lithium could replace copper because it's above it. It's more reactive. Also, the same thing happens with the halogens, that whether or not they can replace another one has to do with where it is on this activity series. So just because you write a reaction doesn't mean that it's going to go. And copper can't remove the hydrogen in water. There's the one I have at school explains that a little bit better about well, I think I might have it here. It's whether or not hydrogen can be replaced depends on whether or not it's in an acid or not. And that's what this is right here. But just in general, metals can replace another one if it is higher than the other metal. Okay, so that's the first thing. And I do teach that to my regular chem as far as this activities thing, but the acids part I usually don't. That's usually more an honors thing. Okay, now the next thing in your book is that talking about net ionic equations. Now what this has to do with is double replacements. If you have a double replacement reaction, let's go back over here and look at it, like this, where the R ends up with the U and the S ends up with the T, that a lot of times what happens when you put this all in the beaker is it just all disassociates and floats around the beaker. And really nothing happens. Instead, when I taught this like couples, it would be like both sets of couples got divorced and they're just single in the beaker now floating around. So if it's a true double replacement, you have to have where a solid or a gas is formed. Then that's considered when, see that's my S or G in my missing handwriting, but that's when the double replacement reaction actually happens. So one thing you could do is write it as a net ionic equation. So like this, see how these are all aqueous? That means these are all just, well, except that one. If they were all aqueous, you would write them and they would just all be written like this as ions floating around. But because this one becomes a solid, that means that you have a solid precipitate come out. That means this reaction really does happen. Something happens more than everything just disassociating and floating around the beaker. So these other things that don't get together, they're spectator ions. They come apart, but then they just float around the beaker and they don't do anything. So what you can do is you can mark out, do you see how they're canceling out? Things that are on both sides of the equation unchanged. This is over here, it's over there, unchanged. The sodium's over here, it's over there, it's unchanged. We can mark them out, and what we will have left is a net ionic equation. It's what's really happening. The silver atoms, the silver ions get together with the chlorine ions and make the solid precipitate silver chloride. So this, whether or not these will happen or not, depends on the solubility rules. And they're in a chart, and you can read them and you can figure out whether or not things really happen. Now, in your book, I don't know if it gives you the solubility rules. I don't think it does, but it just tells you if something becomes a gas or a solid precipitate, and then you can write the net ionic equations. For my honors kids that I'm teaching right now, they have to look at the solubility rules. They have to figure out if something is insoluble, if it'll be a precipitate, and then they have to predict the products, figure out the oxidation state so they can figure out the subscripts and write the reaction. And then if everything's aqueous, then they write no reaction, because really everything just disassociates in the beaker. All right, so this is an optional video for you to watch. You can find out more about this if you're interested in it, but I want to at least let you know it's out there and sort of explain it to you. Science is great. See you next time.